Hello everyone. So today we're having a look at I hope that's a bit clear. Today we're going to have a look at two more algorithms. Okay, these are the quick sort and the simple sort. So I've saved the most complicated and the simplest for last. Okay, sorry, I'm having issues with this. I just try and fix it. Yeah, that'll work. As good as it used to be. So let's have a quick look at quick sort. So quick sort, as it says, is pretty quick. So I'm going to start with an example. Here's a list. Okay. Oh God, this is a disaster. Hopefully that works. Sorry now. So quick sort. Let's think about what it's going to do. It works on what's called a pivot point. So you have to pick a particular element of your list around which the actual sort will happen. There's lots of ways of picking it. You can pick the first element of your list. You can pick the last. You can go random. Or you can go the middle or median. I always go with the last. No matter what it is, I'll always go with the last element of the list because, you know, it's probably usually the easiest. The last and the first are the easiest to code for. First element of this is always be at index 0. The last will always be at, you know, the length, you know, or -1, whichever you want to look at it. Okay. So I always go with the last element of the list, and then everything gets pivoted around here. So what's the algorithm for this one? Right. The algorithm is, you know, pick an element. Okay. Pick an element. If, and then you loop. I'm going to loop through the rest. So I'm always going with the last. I'm going to pick 70. I'm going to loop to the rest, and if greater than 70, you append to list 1, else append to list 2. Okay, so once you've done that and you've created 2 new files of all the numbers less than or greater than 70, they become 2 new lists. Okay, and then you repeat the process in both of those lists. You find the last element of each list and you pivot everything else. It's either greater or smaller than that. And then they're shoved into a new list until finally you've got all these little mini lists, each containing 1 element, but they're all in the correct order. So you'll see it as we build it. So we're starting with this. This is our pivot point. Okay, so we're starting with 70. So loop through your list and find any numbers greater than 70 and put them into a new list. Okay, and then any numbers less than 70 go into another new list. And unfortunately, these are in order. And you're just realizing that anyway, but listen, it's good. So now let's start with this one. 80. Okay, any numbers less than 80 go into a list on this side. There are no numbers less than 80, so it's an empty list. And any numbers greater than it go on this side. So they're done. See, got those 3 done now. Okay, there's nothing in this list. When I put that as a pivot, and I looked through that list and I found nothing. Okay, there's nothing in it. Okay, so I'm going to leave it empty. I'm not even putting a 0 in it. It's empty, but this one has a 90 in it. But they are in order because if it's greater, you put it in to one list. If it's less, it goes into another list. But if there's nothing in that other list, if it's empty list, it won't be counted when you're putting your list together. Now on this side, I'm pivoting around 50, haven't I? Okay, so if there's anything in the list bigger than 50, that's empty. Anything less than 50, put it into another list. Okay, you see where this is going? Now we've got 40 as my pivot point. Anything greater than 40, put it into a list, it's empty. Anything less, put it into another list. Now, 30 is my. Anything greater than 30, put it into a list. Anything less than 30, put it into a list. And add up, put all my lists in order now. 10, 30, 40, 50, 70, 80, 90. And there it is done. That's your quick sort done. Okay. Now, the advantage obviously of quick sort is it's ridiculously fast. It's a divide and conquer method. Just like when you were doing your binary search, you're splitting, you're splitting, you're splitting. So you're having to do less work on smaller lists, which will act quicker. The problem is each time you're building a new one, you're actually using more memory. So it does actually take more memory. It don't have to be ordered. That's the beauty of this. It will order it for you. Okay, that is the beauty of this list. Okay, so we'll do it again with another example. Okay, we'll do another example. We'll use a tougher example this time just to show you how cool this is. Okay, so we'll do 7 minus 2, 4, 1, 6, 5, 0, minus 4, and 2. Okay, so I mean, you're not going to get much more random or unusual than this one. Okay, so let's give this one a go. We're going to pivot around 2. So we want all the numbers bigger than 2 on this side. So we've got a 7, we've got a 4, we've got a 6, and we've got a 5. Okay, and then we've got all the numbers less than, we've got a -2, we've got a 1, we've got a 0, and we've got a -4. So I haven't put these in order. That's the beauty of this. They're not in order. So now we're going to pivot around the 5. So what's our rule? Any number bigger than 5 will go on this side. Any number less than 5 will go on this side. So the two numbers bigger than 5 are 7 and 6. And the two numbers less than 5, what do we got? Just 4. Okay, so he's already sorted. So we have to do one more pivot here. Okay, so we've got 6, and then you'd only be left with a 7. So look, 2, 4, 5, 6, 7. So all the ones in the circles have already been sorted. Now let's do this half. Remember, this is both happening at the same time. I'm only doing this because God knows I haven't got the brains to be doing 2 sets of different hands at once. So we're pivoting around the -4. Okay, so that's the one I picked. So I want all the numbers bigger than -4 on this side. So that's whatever, a 1 and a -2. Well, no, it's all of them, isn't it? It's -2, 1, and 0. Okay, now we're going to pivot around to 0. Okay, we're going to pivot around to 0. And we've got one bigger, and we've got one smaller. So let's see, do we have everything? -4, -2, 0, 1, 2, 4, 5, 6, and 7. -2, 0, 1, -4, 2, 4, 5, 6, and 7. Okay, so that is our beautiful quick sort. Okay, there's another one very similar to it called a merge sort that you'll often find a lot, especially in GCSE and English stuff. But we're using the quick sort here, and it is a very nice little piece of kit. It's easy again to spot in Python code because you can see what you're doing. You're using a conditional statement to go greater than or less than and creating new every time. Okay. Very nice, lovely little piece of code. Now, our last piece of code is our simple sort, okay? And it literally does exactly